Okay, so we are also live on YouTube for anybody joining there. This is some interesting stuff. So I didn't know Google Meet as a hijack OBS and then Yonyeshe. So when I'm displaying the ID, can you guys still see me?
If you go back to OBS, you
Uh,
can click on just anywhere in OBS where it's
mm.
the line pixel.
Oh yeah. Ivo.
Yeah, that's
Yeah, but you can see me here. Oh, okay. Awesome. I think this is good. I'm even glad because I only thought it would only work for I thought it would only work for the live stream, but I'm glad it's also working for Google Meet. So Ian, maybe unaweza salimia watakuwa kwa live stream. Say hi to the people on the live stream, Ian. Lazima nirudi side ndio uonekane. Okay. Sawa, wamekuona. Okay, so let's start. So last time we looked at a comparator interface and comparable, which we documented really well, I think, in one of these folders. Sorting, yes. Sorting class. So on this sorting class, we were able to, I'm hearing some background noise. So we were able to look at comparable and comparator, and the main thing we learned about comparable and comparator is with comparable you can implement your own natural order sorting. That is, you can go into the class in which you declared the in the class in which you declared the object. I think that is the other example. So you can go into the class where you declared the object, like this ticket class, and you can have ticket class implement comparable, and you can tell it the type, which is basically the type of class you're declaring, and then you can implement this compare to function. And now when you call collections.sort without passing a comparator, it will do natural order sorting for the values based on the criteria you gave it for sorting. The other thing we learned was that with comparator, it allows you to implement more than one sorting strategies. So for instance, with this person class, you can create a sort person by age comparator. So this will sort the person by age. You can create a sort by name comparator, and this will sort the person by their name. I'm seeing that I'm blocking some of this. Let me just make a small adjustment here so that I don't block too much of what we are covering. Yeah, so so you can implement multiple comparators for the same class, and the way you use it is you call collections.sort. You pass in the list, and then you can pass in the comparator. So for instance, this will sort by age, and this will sort by name. So you just pass in the list, and then you pass in the comparator. So today we'll continue our tradition of looking at interfaces, except that we will be looking at a different kind of interface. Yes, question?
Yeah, sorry. What's the difference between the comparator and is it comparable?
Comparable.
What's normally the difference?
So comparable allows you to implement natural order sorting. By natural order sorting, since you implement it directly on the class or the record in this case. So here we have a record ticket, and it implements comparable, and the compare strategy is defined alongside the class. So anytime anybody creates a new instance of this ticket class, they'll be inheriting this sorting order. But comparator allows you to define it externally. So the advantage of having it in line like this means when you're comparing, you don't need to again tell Java how to compare the object. So when you call collections.sort, like so, and you pass in the list, you'll notice that we are not, usually you need to pass the sorting strategy here as a comparator. So you need to pass a sorting comparator alongside this to tell collections.sort how to sort these tickets. But if the class declaring the ticket already implements comparable, the sorting strategy is already implemented inside the class itself. So for instance, if I run this, just to see, though the output might not be very obvious, but you will notice we have, so we have a before sorting print. So we're using iterator here to print before sorting, and then after sorting, after we call collections.sort, we print it out again using the iterator. And the way the output is, you'll notice that okay, I have two after sorting here. Okay, let me demonstrate this with a new example. Using the old one is going to get a bit tricky. So let me call this sorting recap compact source file. And let's have a simple class. So I'll define a simple class like point. Let's use something that has different properties. Let's use something like a game, so like a football match. And this game, okay, let's to me a team. So team, you have a name for the team. Then you can have number of players. So number of totally available players. I'll use a record for this so that we have an easier time. So I have my record team. I can create a list of teams, and that will be my array list. And I can add some teams to this. So I can say add new team. And this with this I can pass the name of the team based on how the record is declared. So I can pass, let's say this is DR Congo. Number of players, maybe they have 33 available players. Maybe I have, okay, let me use something in that, number of goals so that it makes sense, or goals. So these guys have 33 goals. I can have Portugal with 11 goals, or maybe 5 goals. I can have another team here, Japan, with 50 goals. So if I just print this list of teams, I can go ahead and print it using an iterator. So I can call teams.iterator to get an iterator, and I can use that iterator to loop through teams. And while looping through, we can retrieve a team and print it. Our team is equals to iterator.next to give us the team, and we can print the details of that team. So since we already covered strings, I can use text blocks here to simplify my work a bit. So this is the name of the team. Will be percentage %s, and we can also have the goals next to it, which will be %d. And here I can use .format, formatted, and say this is team dot name, that one, and team dot goals. So this should print the teams and the goals they've scored. So if we run that, we'll see we have DR Congo 33 goals, Portugal 5 goals, and Japan 50 goals. Now, what if I wanted to sort these teams by, every time I want to sort the teams, I want to sort them by the number of goals they scored to see whether they were qualified for something. So one way I can do it is I can use a comparator or I can use a comparable. So let's start the first example with using a comparable. No, let's start with the comparator first. So to use a comparator, we have to define a comparator as a separate class. So we create a class sort by, perhaps this is sort by name comparator, and it implements the comparator interface. And the comparator will be using type team. So it will be sorting team. So that's what we pass in. And inside here, we override one method in comparator, which is compare. And this will compare team 1 and team 2. So this will be team 1 and this will be team 2. And what we return, as we discussed last time, you can return either -1, you can return 0, or you can return 1. So you return 1 if team 1's value, the value you are comparing, is greater than team 2's value. You can return 0 if they are the same. You return -1 if it's in reverse, if team 2 is the one that has a greater value than team 1. So depending on what you're comparing. So here we are comparing the name. So it will look at the alphabetical order of the names. And we can use some available utility functions in Java to help us with that, particularly string. So string has a way of doing that sorting comparison. So we can say compare to team2 dot name. So that will compare team2 name versus team 1 name. So during the sorting, of course, you guys know how sorting algorithms work. You move element by element as you compare two elements. If the next element is greater than this other element, then you can move one element in front of the other, and you repeat that process until the collection has been sorted. So in this case, we'll be sort of doing the same thing. So now we can use this comparator to sort the teams. And the way we do it is you call collections dot sort, and you pass it the list of the teams, which is the list here. And next to it, you pass the comparator. IntelliJ, I'm not liking the way IntelliJ does these pop-ups. Sometimes there are too many. Might have to move to Bing. So the comparator in this case will be an instance of our sort by name comparator, this one. So I can create a new sort by name comparator and pass that as the comparator. So what this means is I'll give collections.sort the teams that I want sorted, and the comparator that the strategy that it should use for sorting, which is this comparator, which means this will look at this compare function and use it for sorting. So if I go ahead and print it as well, I'll just reuse this function here and reuse the iterator. So these are sorted values. Let me prefix with sorted. And if we run it, we'll see before sorting, we have Congo, then we have Portugal, then we have Japan. After sorting, we have Congo with 33, we have Japan 50, and we have Portugal 5. So they've been arranged. So since Portugal has the lowest, it has been put as the third element, then Japan, then Congo. In fact, since coincidentally this is going number based, let me use some alphabetical names that can make sense to us, that will be easier to visualize. Let's say you have USA, you have a team that starts with A, maybe Armenia. Let's imagine Armenia qualified. And we have Denmark. So that is A and D. So we expect that if we sort by name, we'll get Armenia, then we get Denmark, then we get USA. So if we run that, we'll see before sorting, we have USA, Armenia, Denmark. After sorting, we have Armenia, Denmark, USA. So it has done the alphabetical sorting. So that's how you sort with comparator. Now, how do you sort with comparable? So with comparable, it's different. You implement the sorting strategy directly on the class. So where we've declared the record teams, we can implement comparable here. So we are not creating it as a separate class, and we give it the parameterized type, which is the object we want to sort. In this case, it's team, and we override the compare to function. So with the difference between compare and compare to, with compare, we compare two elements because we are not declaring this inside the class itself. It's not an instance function. It's not like a method in the class, but this is a method in the class, which means we have access to this, and this will reference the instance that we start the comparison with. So what we are passing here will be the other team. So we already have the first team. The first team is, the first team we are using for comparison is this instance. And we can use the same strategy we used here. Just return, because also this uses the same strategy. This int value can either be -1, it can be 0, or it can be 1. -1 if the second one is greater than the first one, 1 if the first one is greater than the second one, 0 if they are the same. And just like in the compare to, we can return this dot name, because we are comparing the name, dot compare to other team dot name. So this would help us achieve the same effect. So now when we are calling collections.sort, we don't need to pass a comparator. We can get rid of this comparator. And if we run it, we should be able to get the same effect that we got with the comparator. So you see, before sorting, we have US, Armenia, Denmark, but now we have Armenia, Denmark, US. So the difference is, with the comparable, you implement it directly on the class, which means when you call collections.sort, you don't need to pass the comparator separately, the comparison strategy separately, but with comparator, you need to pass the comparison strategy directly. So that's why I was saying with comparable, you can do natural order sorting. With comparator, you implement the sorting strategies as separate classes and you invoke them as needed. The advantage of comparator, you can have many comparators, but with comparable, you can only do this once. You can only do this once for any type. So if you implement this sorting strategy for this team, then that's cast in stone. You can't change it. But with comparator, you can have like 100 sorting strategies. Ian, does that?
So safe to say it's the most common one is the comparator because of the extensibility and the flexibility.
Yes, absolutely.
Unless you want to limit your.
Exactly. In some use cases, you might want to limit the ordering if you don't want somebody implementing a new sorting strategy. So you might decide for this thing, you can only sort it with this strategy, no more. Maybe you don't need to like implement. Although the good thing is you can have both by the you can eat your cake and have it. You can have the comparable where within the class you have a sorting strategy, but also have a comparator for when somebody wants to use a custom comparator.
Okay, and then for like simple methods, you can do them in line, or in comparator.
I do them in line, as in?
Instead of creating the custom comparator,
you
can just have to create it there.
So are you insinuating using lambdas?
Sorry.
Are you referring to using lambdas to do it in line?
Yeah.
Yeah, you are jumping the gun. Oh, yes, Joe. Go ahead.
Yeah. So yeah, in your code, I think the comparator extension, the sort by name comparator, I don't think you need to create a class you can actually initiate it as a static variable. So you can write comparator. It's like an, what do you call it? Anonymous way of,
Anonymous class.
yes, just press enter before the class declaration up there. The sorted,
Hit there.
yeah, there, and there. And then write comparator.
A comparator.
No, the class itself.
Comparator. Like that.
Yeah, and then the diamond team. And then space sort by name. Then is equals to a new comparator, I believe.
Oh, like that.
Yeah. Actually, NetBeans does it automatically.
Yeah, IntelliJ. This is how lazy programmers are born. Yes.
Okay. And then now you can use it directly.
Oh, so here we can do that's O1 dot name dot compare to O2 dot name, like that.
Yeah.
Nice.
And then you can use it now in a method.
Okay.
So now Joe.
Yeah.
So for a case where you where we want to say, for example, create, I'm not really sure whether this is an ideal case, where we want to create a generic comparator.
Yes.
So that means we'll not go with the anonymous way of creating it, no?
Like TT, like for example, the generic type is parametric T.
Yeah. So we want this specific comparator to be applicable to our entities if we have like various classes.
Unless the type itself is extending an interface, and that interface has specific method to return a value which you can now compare.
Yeah.
The problem is it's such an approach is not type agnostic.
Yeah.
Types have different what do you call it? Behavior or meaning or something.
Yeah. So yeah.
But this approach is what we call separating behavior from a type. That's the difference between comparable and the comparator. Yes, and that's a huge design mistake. Actually, it's something they discovered later, because even if you think about it, when iterable, it's the same thing.
Same issue.
And also auto-closable, it's same issue. Yeah, so if you separate behavior from type, you can actually do amazing things later. Yeah. For example, if it's an interface that has methods add, plus, minus, and then you do the way we have done here, in future the compiler will be able to notice such things and then do operator overloading. Yeah, Haskell does that throughout, and they have been benefiting from it for a long time, almost 4 decades. Yeah.
It's good that we're getting all of these enhancements in the language, but also I'm hoping we don't become C++. I'm hoping that we don't add in these modifications and then eventually we have 2 versions of Java, because with the Java ecosystem we have this problem of backward compatibility. So if they add ways to for instance, do, I think you call it data-oriented programming or something like that.
Yeah.
Some of these facilities, like using comparable, which embeds behavior inside the class declaration, most of that they won't be able to remove from the language because a lot of major projects depend on it. So they'll sort of have to build some things on top of the language. So I just hope that they're not careful to explode the number of features and then end up introducing complexity. I don't know if you get what I mean.
Yes. So let me show you a mistake a certain language has done. So like iterable, what do you call it? Auto-closable. Those are syntax enhancements in a language. So for example, the unique for loop uses the iterable. So Kotlin decided to introduce collection literals, whereby you have collection C is equals to yeah, I think it will show you properly. Yeah. I hope they show the syntax. Oh yeah, just go up there. Now zoom in. Yeah, zoom in. Yes, yeah. So for this to become a collection literal, maybe that class or the list itself has to extend an interface called collection. So if maybe a library forgot to do this, it will be impossible for someone else to take advantage of acquiring collection literals. So somehow you limit yourself to certain classes, and you cannot implement such rules in different types. Yeah. So the idea is not to disturb other libraries. It's to separate the type from the behavior. Yeah, so they're like extension methods, but with rules, so that you don't misuse. So unfortunately, you have to extend, I think, collection or something, so that you can use this. Yeah. So if a library that has a lot of lists, custom lists, if they never extended the collection interface, they won't benefit from such kind of features. Yeah. So that's the flexibility. Yeah.
If the library is forced to implement the collection interface, would that be like a good thing? Or that would tie it down to the object graph type system, and now we are looking into primitives becoming first-class citizens. Because
Yeah, it's a huge limitation, because another thing is that if they decided to use iterable everywhere in the Java libraries, that it's like code pollution. Yeah. So for example, let's say a type is a collection, and then it needs operator overloading. It has to extend many interfaces. That actually makes your code get polluted with certain interfaces, and it doesn't force you to depend on a dependency like library, for example. Yeah, it's so isolated. That library can work without those interfaces if it had that separation of behavior or type. Yeah. So you don't have to download this dependency because this dependency has this interface. Yeah. And that's why people from Haskell, Oka, those functional programming languages, they tend to be quite. They usually love their languages because of such kind of features, whereby it never complicates. The problem why we are a bit against such kind of approaches that we are not used to it. That's why. Yeah, we're not. Yeah. But you can research about it. By the way, the brand did a very good presentation about it. You can go and study. Because even, for example, in future, if you make a float 16 where the float itself is 16 bytes, 16 bits, I mean, it means I can cast it to a float because a float is 32 bits. Do you embed that behavior in that float 16 to cast? Yeah. So you can do that behavior in a separate library so that you can get such kind of, it opens a lot of enhancement to the language. Yeah, but that's a digression.
These enhancements come in a sober way, in that we don't pile features on top of each other. So at the end of the day, the features that are new should, at least for me, must feel like they've always been part of the language. So when you're using them, they don't feel like a new thing. A good example is when I'm using records. Records feel like classes. The only thing is how records will behave at runtime, and a little bit of restriction in, for instance, copying, immutability, and stuff like that. But it feels like I'm using a regular class. There's no excessive syntax sugar. It's just the only change is, instead of class, I use record declaration, and the syntax of the constructor is slightly different. So changing the language that way, I think I'm more in favor of, as opposed to they introduce a feature and it feels like you're programming a different language. You get what I mean?
Okay. Okay. Another thing, think about how other languages have abused operator overloading, like C++.
Especially C++.
Yeah. So even Kotlin you can use operator overloading. Yeah. So if you separate behavior, they have to implement all those methods for that to work for this type. So it brings a lot of sanity. But that's something I think in the next 3 years you'll be able to learn more about it once it's introduced. Yeah.
I'm happy that the way Java is adding these features is less syntax sugar, and the spirit and the structure and the flexibility of Java, in that you can program it in any way, I think makes those additions not feel too disruptive. And most of them are optional. Just like in Java 8, we got functional programming, but you can still write imperative code in Java. Nobody will beat you. You can write OOP, there will be no problem. And also you can do functional to some degree, and it will feel like you're still writing Java, which I think is very nice.
Yeah, I think Kennedy wanted to ask something. I don't know.
Yes, Kennedy?
Can you hear me? Nini, Joe, the Kotlin thing, sijui umeitaje, when they declare the collection like that, is it immutable, or can you add things on top of it?
I'm not sure, because it might be because it can do deconstruction also. For example, you see the way it's written, val L is equals to 1, 2, 3. In val L, you can put it also in, I think, curly brackets, and then assign variables for each slot. And deconstruction doesn't like mutability, so probably it's immutable. It targets immutable arrays. Collections. That's what I suspect, but I haven't tested it or done any experiments. But you can advise, you can test it, and then maybe next time you tell us. Yeah.
Kotlin. Is that I'm reading Clojure. Yeah, thinking in functional is very difficult. Everything is immutable.
Yeah, Clojure is very difficult. I don't know it actually.
They have something like this. Actually, they are everything is function. They have something like close to this. The way they are doing it, just doing it because they have forced me to do.
Yeah, you should see how they deal with I/O. you'd be shocked. Any functional programming language. Actually, I've seen memes of how do they deal with mutable states. For example, reading files, waiting for something through a network. Yeah. So because functional is all about immutability, but such situation, mutability is very important.
Well, you end up doing a lot of copying, right? Because
Yeah.
you can't update the same object. So you have to create a new instance and then copy those properties to the new instance.
Oh yeah.
So I would imagine if, for instance, you have a buffer, you're reading from a file, and you have a buffer, you'll constantly, instead of just updating the same stream as your buffer gets filled up with new data, you have to, every time the buffer is reloaded, you create a new copy of the object, and then copy that over to another object and then create, which makes the language, makes the program itself, I would assume, potentially inefficient. Because if you're constantly initializing things, there's some computation, extra computation you're using, and also you'll end up using some additional memory. I think that's what brought the whole debate of clean code, poor performance by that guy on YouTube. I looked at these ideas where you like use functional programming and your program looks really beautiful, but the inefficiencies that you inherit from that beautiful program is enormous.
Some of them claim their concept of functional Nini is fast. Actually, Nini, the closure, whatever, even if their data is immutable, there's a way they are doing a certain concept, they are calling it persistent collection or something, a persistent object. So instead of copying everything to a new instance, there's some sort of way under the hood sharing the initial one, or I don't know. And then I asked myself, so if you guys are doing this under the hood, why don't you allow it to be fanya pia? Then
It's the C argument. They say C is dangerous because it allows you to do a lot of things, like you can play around with memory the way you want. But in real sense, the only reason in Java I'm not playing around with memory dangerously is because the JVM is playing around with memory dangerously on my behalf. So that I can just write ridiculous programs and I know that I won't have like a segmentation fault or writing out of bounds and stuff like that, because the guys writing the dirty code in the JVM are the ones doing the dirty work for me. So I think it's the same thing. So they're doing that copying internally, and because now you're not doing it as a developer, it's made to seem like an advantage, but in real sense, we're just delegating that responsibility. So this is starting to feel like Java by example, which is supposed to be on tomorrow. So we are supposed to be doing Java for everyone. But thank you for the interesting discussions. Anybody who finds these discussions stimulating or exciting, make time on Friday from 8 to 10 p.m. We usually do that for 2 hours, and we have these interesting expert level discussions on not just Java, but also how Java compares with other languages and platforms in the developer ecosystem. In fact, tomorrow we'll be having Joe taking us through foreign function and memory API, and he'll be basically demonstrating what you can do with interoperability between Java and low-level languages like C and C++. So if you are ever curious about how you can call C code from Java and call or C code from C++ code from Java, we'll be doing that tomorrow. Joe will be taking us through that, and we'll have a very good discussion. So if this is something you're interested in, make sure to join us tomorrow, 9 p.m. Kenyan time, and we'll be able to see how well that discussion fits. So Joe, you are set for tomorrow, right?
Yeah, hopefully.
We are counting on it. We are really counting on it. Situangushe.
Okay.
Situangushe.
So,
Okay. Okay, so so that will be on tomorrow. So let's continue with what we had planned today. At least we've done a recap of comparable and comparator. So I'd like us to do a small. So there's a concept Joe has introduced here, which is anonymous classes. So if this code is confusing for you, I think it might have been covered in OOP. Kennedy, did you cover anonymous classes in the OOP phase?
I don't think it was covered because Nani Steve was the one who was doing it.
Okay.
Yeah, I don't think it.
Okay.
I'm not sure anyway.
Oh,
I don't think it.
no worries, no worries. So we'll do something adjacent, and then that will help us understand it even. It will make this look rather inefficient once we cover the other things. I mean, inefficient in terms of syntax, not performance. So anybody have a question on comparable and comparator in this comparison sorting strategies? Okay, so it seems there are no questions. So then let's look at functional Java. So we are supposed to cover functional programming in Java in a later part of this online bootcamp. But because there are some functions within the collections framework that can benefit from an aspect of functional programming, particularly it can benefit from the idea of lambdas. So I thought perhaps we can look at lambdas and functional interfaces, and then do like an not a complete in-depth look at lambdas and functional interfaces, but just enough to allow us to interact with parts of the collection framework that depend on lambdas and functional interfaces. And then when we get to that part of this online bootcamp, we'll have a much more in-depth coverage of functional programming in Java. We'll look at some other concepts like predicates and consumers and stuff like that. But for now, I just wanted us to look at lambdas and functional interfaces and see how we can use those to benefit from some of the features in the collections framework. So the main idea, and anybody here who has done extensive functional programming can add to this discussion, but I believe the main idea in functional programming is, I'll refer to it as FP. The main idea in functional programming is functions as first-class citizens. And for me, based on my experience with functional programming, what I understand with this idea is it basically means that you can use functions the way you'd use variables. So if you imagine we have a variable int n, which is perhaps 10, we can have a function like public void count. Let's say this is a function that can count, and we can pass this n into this function. So it can be an argument to a function. So the thing with functional programming is instead of being limited to only passing variables, here, we can pass functions. So you can have a function do something, and this do something can receive operation 1, which is a function, and it can receive maybe operation 2, which is a function. And this operation 2 can be used inside, operation 1 and operation 2 can be used inside the function to perform operation 1 and to perform operation 2. So you can refer to those functions inside this function. So here we have functions as arguments, and those functions can be executed inline inside the inside do something. And some languages go as far as allowing you to declare functions within functions. So I can have a function here like void operation 3 that's declared inline inside this function, and I can give it something that it does. So it does X, and having declared it inline, you can even have it execute inside the scope of do something. So this is what we'll be looking at today. We'll try and create some first-class citizens, first-class citizen functions. We're going to give functions citizenship in the language so that they behave more like variables. So with that, let's check out an example here. So let's say we have a classic OOP example. If you have a car, the main operation that a car can do. So let me just recap. So in OOP, the way we would arrange the relationship between cars and other vehicles is we can have a class vehicle, and this class vehicle can be a superclass, and you can have a bus implement this vehicle. And when it implements the vehicle, it means that we are able to transfer functionality that was declared in the vehicle to the bus. You can have another type of vehicle like sedan, or which other type of vehicle, like a truck that implements as well. Since this is a class, so this bus can extend vehicle. So you can have another truck here that extends vehicle. So both of these will inherit the properties of vehicle. So we can do such a similar relationship with interfaces. So we can have an interface vehicle that has some abstract functions. And I know I'm preaching to the choir here because we've covered this. So you can have a void drive inside this vehicle interface. And when bus implements, when the bus implements the vehicle, it will override this drive function. So we'll be able to override the drive function. And also when track implements vehicle, it will end up overriding the function drive. So it will also override drive, which means it will add its own custom functionality to drive. Now, using a functional approach to this, we can consider a truck and a bus to have one characteristic, which is that they are all drivable. So you can drive a bus and you can drive a car. So instead of referring to their their top level behavior as, yes.
Anything?
Oh, whoa.
It's showing your desktop.
Oh, it's not showing the ID.
No.
Okay, I think I might have missed something here. Let me try and sharing again. Share screen. I hope that has not been for too long. Can you see my screen now?
Perfect.
Awesome. Thanks for that heads up. It happens. If it happens again, let me know so that I can fix it. But thanks for that. Yeah, so the main characteristic between the bus and the truck is that they are drivable. So we can rename our interface. Instead of calling it vehicle, we can name it drivable. So that will make this interface refer to anything that can be driven. And when drivable is implemented by any of these other classes, drivable. When drivable is implemented, there will be a requirement to override the function drive. So let's get this and see how we can use this. You can implement this this behavior. So let's write some real code. So you can declare an interface drivable, and this interface has the function drive. Abstract function, it's not implemented. And now we can have a class bus, and this bus implements drivable. It implements drivable, and because it implements drivable, we can override the drive function that's been declared abstract, and this drive function will just handle driving. So can say this is driving bus. And also with the truck, we can also implement drivable, and by implementing drivable, we can override it and we'll get drive there. So with this, we can say print line, and we'll be able to get driving truck. So we have driving bus and driving truck. So the way we would use this is we can have an instance of drivable, and this is a truck, and we say it's equals to new truck. We can have drivable, and this is a bus, and we can say it's equals to new bus. So both of them are drivable. And when we call truck.drive, which is a function that's available, remember I'm referring to drivable now, and when we call bus.drive, we should be able to see what we get there. So we'll see when we call truck.drive, we get driving truck. Although it's drivable, its implementation is truck. When we call bus.drive, we get driving bus. So that's how that relationship can be passed down. So this is just a recap of inheritance, but it will be important what we cover next. So now that we have this, let's imagine we have a static function that is outside this inheritance hierarchy, and the static function, all it does is it registers it does a global drive, for instance, let's say. So this is a global drive, and what it does a global drive, and it doesn't care which bus, or whether it's a bus, whether it's a car, whether it's a truck. All it does is it checks whether that thing is drivable, and it drives it. So you can imagine this is a very experienced driver. So they are not limited to a bus or a truck. As long as something is drivable, it will be able to drive it. So you can take that and drive. Okay. So now within our code, we can call this global driver and pass it a drivable, like a truck, and it will drive that. We can also call that global driver and pass it a bus, and it will drive the bus. So just like in the other case, we'll see that when we call global drive the truck, we'll drive the bus. Now, what we are seeing here is we are not passing data to global drive. We are passing behavior. We are passing this function drive. So in this case, we are passing drive that has driving bus. This other case, we are passing drive that has driving truck. So since we are talking about functional programming, and we just learned that in functional programming, you can actually pass functions as arguments. So instead of passing data, you can pass this function, this one, as an argument. So why don't we just pass the function instead of passing this drivable? So what we can do here is, since this receives a drivable, we can decide to pass the function. So you can copy this function, and so this is when we are driving track, we can pass that here. Okay. And when we want to drive a bus, we can take this drive bus function and we can pass it here. So according to functional programming, this should work. And before Java 8, this was not possible in Java. You could not do this. But after Java 8, there was an introduction of something called lambda expressions, or lambdas. And lambdas, what they allow you to do is essentially this passing functions the way you'd pass data. And this passing of functions is valid as long as I alter the syntax a little bit, remove the things that we don't need. So first of all, we don't need access modifiers because this will be limited to one scope. The other thing we don't need the return type. So since we're returning void, we don't need that return type. Also, we don't need to name the function because we're just using it in one place. It's not a variable. And then the other thing we need to add is this arrow function. So we can add an arrow function, and this just says this is the function arguments and this is the function body. And you can see now this is valid Java. So you can actually run this. So if we run it, in fact, since now we are functional, we no longer need these guys because we're able to pass the behavior. We moved from passing data to passing behavior. And if we run that, we can see that we have driving track and driving bus, which is these two behaviors that we're able to pass. So this is how you can pass functions as arguments. And the only reason why we're able to pass that function as an argument is because our global driver receives a drivable. And what does a drivable do? It implements drive. So we can just pass that drive operation instead of passing a bus or a track. So you can forget about objects. So in OOP, it's usually object-oriented programming. So you can remove the O from objects and just pass the operation when you're doing functional programming. And this can be made even better by simplifying it, removing those extra braces, and making this in line so that it's more concise. So this would be valid Java code. So if we run that, we'll see, we'll get a driving track and driving bus, which is the operations that we were able to pass. Questions? Questions or comments? Those who are familiar with functional programming, if I missed anything. Okay, I think the thumbs up means it's clear. Okay, awesome. Let me see if there is any question in the chat. Okay, wonderful, wonderful. So now, since we are doing this, it means we don't even need these class declarations. We are no longer doing data-oriented. We are no longer doing object-oriented programming. So we can get rid of that. So we don't need that. So we end up with very concise code. We have an interface drivable with a function drive, and any global driver can receive the drivable as a function. So think of this as a function and use that as an argument. So here is where things get interesting. Remember the concept of functions as first-class citizens. So functions as first-class citizens. So where we are treating functions as variables, we can actually convert this function into an actual variable. So the same way you'd have var int, this function can be var drive. So this is drive track. So it can be a variable. Of course, it will need to be drivable. I can't use var everywhere. I wish we could. But this is a variable, and we can pass that the way we would pass int a and then pass it to a function. So we can pass this drivable into global drive. The same way, we can extract this drive bus we can extract this drive bus operation here, just highlighting, and we can make it a variable, and we can pass it as an argument. So we can pass that drive bus operation. And if we run it, we're able to see that passing them as arguments doesn't create problems. So which means you can actually store this operation somewhere and pass it to multiple other functions. Since it's a variable, you can have it somewhere, and then the same way you can have somebody's age stored somewhere, and then you pass it to a function A, function B, function C, function D. It's the same thing with this drive operation. You can have it as a variable somewhere, a global or local, and then you can pass it to multiple functions. So for instance, this drive track can still be passed to this other function. So that is how you pass around functions into other functions. But this global drive is just a static function. It's still a function, and we are passing a function to it. So what if your function receives an argument? So for instance, when somebody drives, you want to get their license. So string license. So we can update our drivable interface and say, before you drive, give us your license. And now, whenever we are doing this drive operation, we must pass a driver's license here. And when global driver tries to drive anything, whether it's a truck, it's a bus, they have to give us a license. And maybe this license has a number like that. And now when they drive, whenever they drive, we need to understand that there's a variable that's been passed, which is this string license. And this is how you, to capture that argument, you can just use, you can use any symbol here. So remember, this is a part of the function where the arguments are passed in. So you can just list the arguments there. I don't like that IntelliJ is adding other things here, but it's just telling us the data type. So this is not code that's required. Just you can just use a symbol. So like this can be E. It can also be explicit like license. I don't know why I use the list there. So it can be license, and here when we are driving, we can capture that license. You can say driving with license that, and say license number is that, and we can do the same way with license number, and we can pass the license number. And now when we run it, we'll see that that argument can, so the license numbers, you can see driving truck with the license number that, driving truck with license number that. So our global, since it's our global driver, whether they are driving the truck or the bus, they'll have the same license number. So we're able to pass that as an argument. So there's a lot of interesting things that you can do with Lambdas. You can let's handle the third case, because since they're functions, they should be able to do everything a function can do. So a function can receive arguments, but also a function can have a return type. So let's say when they drive, we want the distance they've driven, the mileage, in kilometers, for instance. So we can return that as an int, and whenever they drive, we want to know how far they drove. So what we can do is, in our driving Lambdas, we can, so in our driving Lambdas, we can calculate the distance and return it. So you can have a return type here, which is the distance. So let's say the way I calculate the distance is using a random number. So random, I think this is new random dot next in. So I'm just using a random number because we don't have the algorithm for calculating the distance, at least for this example. And here we can also return. So imagine there is a very nice sophisticated algorithm for calculating the distance hidden somewhere there. And you can see that. So we're able to return the distance. So this is the distance they've driven. To make it a bit more clear, we can have a variable here, distance, and we return that variable, distance. The thing you need to remember is whenever your lambda, because this is what we are referring to as the lambda, so whenever the body of your lambda spans more than one line, you need to use these curly braces, and you need to use an explicit return argument, so that you explicitly tell it at which point you're doing the return. So you can inline this, or you can have multiple, you can have a variable and return that variable. So that's entirely up to you, depending on how you want to make that implementation. And now, since this gives us the distance, we can go ahead and try and use that distance. So let's see. So first of all, let's run it and see. So you can see we have the license. After the lambda is executed, global driver. So when they drive, after they drive, we expect that after this drive, we get the distance, the drive covered. So here I can say distance, and we can print the distance inside the global drive function. Distance covered, or distance is that distance in perhaps kilometers. And if we run it, we should see we have the distance here in kilometers. I didn't do bounds, so it's just a random number being printed. So essentially, you can pass arguments, you can return values from the lambda, and you can pass the lambda into other functions. So any questions or pointers that I might have missed? Anything that I probably didn't explain as well? Questions? Okay, thumbs up if you guys understood it. Thumbs down if you can't hear me. I see Joe understood. Steve, is it clear what the lambda? Okay, so that's good. I'm glad we're in the same page. So this is what you can do with the lambdas. So what makes this lambda thing important for us? This is where it gets interesting. So in Java 8, there's this idea of functional interfaces. Functional interfaces. So a functional interface in Java is an interface with one and only one abstract method. Abstract method. So not more than one abstract method. And remember from our recap of interfaces, interfaces can have multiple types of methods. You can have, so interfaces can have abstract methods, methods. They can also have default methods. And recently I learned that they can have static methods. I don't know if this is true, but the most common ones are you have abstract methods and you have default methods. So an abstract method is, for example, this. Somebody in the chat can confirm for me if this idea of static methods in interfaces is true. Interesting stuff. But anyway, abstract method is like this, and default methods is like we covered when we're doing interfaces. So you can have a default method here that perhaps does register stop. So maybe they have multiple stops they need, and it's of course it's a method, so it's a return type, and all it does is it registers the stop. So I.println register stop at perhaps a particular timestamp, maybe system.current time. So you can just register the stop at whichever time that was. So if they stopped, this function will be able to register the stop. So this is a default function. This is an abstract function. So interfaces can only have one and only one abstract. Functional interfaces can only have one and only one abstract function. And the reason why they need to have only one and only one abstract function is because if they have more than one abstract function, you cannot use them as lambdas. Because with interfaces, you have to implement all the abstract functions in there. So if we had another abstract function here, like void stop, so you are driving, you can also stop. If we added this abstract function, we'll see that all our lambdas are now broken. They're gone, they're kaput. They're gone because this mechanic of functional programming in Java depends on functional interfaces. And functional interfaces are interfaces that have one and only one abstract method. If there's more than one abstract method, you're going to, your whole program will go into a stroke and it will stop functioning. So, so that's something important to remember. So because of the idea of functional interfaces is how we get to have lambdas. Without that, we can't have lambdas. So if your interface has more than one abstract function, you can say goodbye to lambdas. And to ensure, because interfaces can be implemented later in your program, you can declare an interface and some other developer will implement it, maybe some user of your library will implement it. You might declare an interface, expect that whoever implements it uses common sense or has the esoteric knowledge of knowing this is an interface with only abstract function. I will not add another abstract function to it, or I will implement it using, I'll use lambdas with it to make sure that you communicate to the users of your interface that it's a functional interface. Java provides a very nice utility annotation that you can annotate your function with. So you can annotate your function with this functional interface annotation. Two important things with this. One, it allows you to communicate to the users of your interface that this is a functional interface. So it can be used with lambdas. Second thing, it allows you to get compile time checking for this one and very important rule of not having more than one abstract function. So if I didn't have this functional interface annotation, I could just go ahead and add an abstract function here, perhaps say stop like we had. So the interface itself will not have, there won't be any compile time errors. So the implementers are the ones that are going to suffer. They're the ones who get their heads chopped off. But if I want to ensure that while I write this, that is already picked up, what I can do is I can have this annotation for functional interface, and I can, by having that annotation of functional interface, whenever I try to add an additional abstract function, that is picked up and it's already detected for me at compile time. So they pick it up and the Java language picks it up and already gives me an error. So you can see multiple non-overriding abstract method found in drivable. So for the only way this code will compile is if I remove that additional function. So if I remove that function, then everything will be very nice. Everything will go very well. But if I have that functional interface annotation and I try to implement an additional abstract class, everything goes sideways. So yeah, so this is very important for you to remember. This idea of functional interface drives into a lot of additional things inside the Java language. It will allow you to work with many additional APIs that we cannot cover here. Of course, we'll cover them later. Namely, as I usually like to name drop the comparator the predicates, the consumers, the producers, and suppliers, which allows you to do other levels of functional programming, and we'll cover them in later sessions. So I just wanted us to understand that. Because we are a bit short of time, we will cover the next bit, which is how this functional interface applies to collections. But before we close, perhaps I can give a quick example. If we have a list of integers, let me call it ints, is equals to a new array list. And inside this list, ints.add, I have a number, I could have another integer, I could have another number there. If I wanted to remove elements from this list of ints, I can call ints.remove, remove the element, and I can say remove 1. I could also call ints.remove, and you can see we have remove last for removing the last element. You can also use ints.remove first to remove the first element. But there's a variant. We've already explored this and we know how they work. This will remove 1, this will check what is the first element, this will remove the first one. So this will check the last element, this will check for the first element, and it will remove it. But there's a variant we're not able to play around with, which is this remove if. And with remove if, you'll notice it's accepting a predicate. And imagine this predicate like our drivable. It's similar to drivable. We are passing drivable to the global driver. So the same with the remove if, it receives a predicate. And a predicate is basically just a way of representing a condition, a true or false state. So a predicate can be true or false. It's like a condition, it's like a Boolean. And it will use that Boolean value, that conditional, to decide whether to remove the element. The different thing with this predicate, or the unique thing with this predicate, is that it's a functional interface. Okay, you see, just the same way we're using add functional in our code, this is also using add functional annotation, and it's an interface. So it's a functional interface. Of course, it's using some generics. We've seen that, so this shouldn't be surprising. And it has one abstract function, which is test, and test just returns a Boolean. So since we know how to use functional interfaces, let's try and use this predicate. We know it has this single function, which means we can use it as a lambda. So if we go back to our remove if, we can say can say predicate. Again, predicate is just like drivable. So it's just like this. Drivable, drive shack, or this other one. Except now we're using predicate. So predicate, this one is working on integers, and predicate is equals to, we know it's a functional interface, so we can use lambdas. So we can use that lambda there, and it's supposed to, let's look at the predicate again. So the predicate receives the value and returns true or false. So it can receive an int, which is a number, and it can return true or false. So for instance, this is a qualifying predicate. Perhaps if I want to only return true if n is greater than 1, so I could say only return true if n is greater than 1. So this forms a predicate. And just like we did with the global driver here, we can pass that predicate to our if function. So if we pass it to the remove if function, what will happen inside the remove if? It will check as it runs through the numbers in the list. Remember, we are calling this on this list. It will check, is 1 greater than 1? If 1 is greater than 1, remove it. Is 2 greater than 1? If 2 is greater than 1, remove it. If 4 is greater than 1, remove it. So this is the condition that will determine whether an element is removed from this list or not. So let's try and use a simple condition, like let's say we use equals. So if n is equals to 1, we remove. And then let's print the values in the list after removal. So let's see what happens. So before removal, we'll have these elements. This is before removal. We'll have these ints, and then after removal we'll have this. So let's run it and see. So we see before removal we have 1, 2, 3, which is all the elements, 1, 2, 3. After removal, we'll see we have 2 and 4. 1 is removed. And why is 1 removed? Because it is equals to 1. Let's say we want to check for every number that's greater than 2. Remove any number that's greater than 2. Any number that's greater than 2 here is 4. So if we run it, if we run that, we'll see that before removal we have 1, 2, 4. After removal we are left with 1, 2. Because 4 is greater than 2, it's removed. The same way we can say any number that's greater than 1, remove. So if we run this, we'll see that before removal we have 1, 2, 4. After removal we are left with 1, because 2 and 4 are greater than 1. So this is an example of how you can use functional interfaces and functional programming to utilize some APIs that are provided under the Java Collections framework or Java Collections library. So yeah, this is just one example. We'll look at additional examples later on that capitalize on this idea of lambdas inside the Java Collections framework. And yeah, and that I think that will be exciting. So questions before I close this, or thoughts? Joe, do you have anything to add on functional interfaces?
Maybe it's considered one of the greatest invention by Java. Many I've encountered so many people say that. For me, I started Java 8, so I didn't know how it was before 8. How bad it was before 8.
I started in Java 7, so it was really tough. It was really tough before Java 8.
Okay. And then they are actually quite optimized because they are given a lot of privilege by the compiler and the JVM in terms of optimization. So you'll notice most lambdas you don't encounter any performance issues, but there are some situations whereby it might bring problems. For example, if it's depending on a variable outside the lambda itself, for example, a local field or something, and that lambda is inside a loop, it will create many objects of that lambda. So there are some situations it's super fast most of the time. In some situations it's very slow. So yeah, but they are quite optimized. Yeah.
Good to know. Also, because whenever you're using these features, you have to be very careful. I remember in one of Venkat Subramaniam's talks. If anybody doesn't know Venkat, Venkat is a legend. Subramaniam is a legend in the Java developer community. This guy, he has taught many of us. He's a legendary teacher. And in one of his talks, he highlights the danger of assuming that lambdas will handle your global variables correctly. And he gave a very compelling example that I'll dig into some of his talks using for each, where you might assume that the for each will run imperatively, the way you write imperative code, and you expect that for each will run a certain way, but instead for each ends up being non-deterministic. So you end up with non-deterministic code because of using for each. I'll dig through his talks and find that example, and then perhaps we can look at it next time. If somebody finds it before I do, please share. Share it because it was a really good talk. I think it's one of his functional programming talks. For now, you should, if you didn't know about Venkat, he's written many books and he's given a lot of talks. So check out Venkat and watch some of his talks. There's a lot of his talks. You can find them on DevOps. So you'll find design patterns, if how to approach refactoring. He's done like 100 or 1,000,000 talks on DevOps. So you should definitely check out Venkat. And I'll find that example where he showed how for each can become non-deterministic. Otherwise, what Joe was referring to is we can have this local variable and we can pass this local variable into the Lambda. So I think these random number generators usually receive a seed, if I'm not wrong. Yeah, so you might pass a seed like that. I hope this is not the bounds that I'm confusing. Yeah, this is the seed. So you see the seed it's in a different scope. So this scope is the Lambda scope itself, but I'm passing a variable that it's outside that scope. So you can also already see the highlighting has changed a bit, and there's some side effects that can emerge from this. So Joe, maybe you might touch on, in this particular example where I'm passing the seed into that, what kind of potential side effects can I expect?
Actually, yeah, there's no issue.
Mm-hmm.
What the compiler does is that if it doesn't capture a variable outside, it will compile that code, the Lambda code, dynamically, but store it somewhere where it will be retrieved every time the Lambda function is called. So it gets super optimized. But now the issue here, if the state, the risk here is that the seed can change. And if you call the Lambda every time in a loop, the way you are explaining, it will create several Lambdas objects because of the state being outside. That's why it's called capturing and non-capturing. Yeah. So capturing, this is now capturing. Non-capturing is when there's no state outside the scope where it's being referenced. So yeah. Yeah. You'll notice most APIs in Java they avoid that. They really avoid referencing any state from outside the scope of the Lambda because it won't be optimized properly. Yeah.
To know, and it's important that you ensure that when you're using Lambdas, you don't refer to external state. Everything you're doing should be within this scope, so that if there's anything else you want to do, you exit the Lambda and then you continue with the operation. But don't refer to external variables that are external to the scope of the Lambda. Inside the Lambda, it might either lead to lack of optimization, like Joe pointed out, or it might also lead to non-deterministic behavior. I'll dig through Venkat's talk and see whether I find that particular example. I know Ian is a big fan of Venkat. Maybe Ian will find that example before I do.
His pictures are always make him look very tall, but he's very short.
Oh, but you guys met him in person on Java Connect.
Yeah, but he's a geek.
That must have been awesome. I feel sad that I missed that one. Hopefully we'll have him another time. But yeah, Venkat is a total legend. Okay, so we've looked at functional interfaces, we've looked at Lambdas, and that was the goal for this session. And also we've seen an example of how you can use Lambdas within the collections framework. And in the next session, we will look at some additional functions in the collections framework that were added after the collections framework was introduced, some enhancements in Java 9 and later versions of Java that actually use this idea of lambdas and functional interfaces, but also we look at some examples that really utilize the default function addition to enhance the collection framework and give it additional capability. but I'm more keen on moving on to a different data structure. That is, we still have set and map. So we've looked at list and we looked at ArrayList. I don't plan on looking at LinkedList, but I'll do a poll and see if you guys want to go through LinkedList. Hardly anybody uses it. Actually, it's sort of discouraged to use it, except for some very special use cases. So my plan is to move to maps. Maps are more interesting than sets. So my plan is to move to maps, and then after maps, we look at sets. Although maps depends on sets, so I might start with sets. Okay, I'll start with sets, and then we'll look at maps. And those two will be super interesting. So I'm looking forward to that, and I hope you guys are also looking forward to it. I think that will be it. If you're watching on YouTube, there was a poll there of which Java version is the greatest, which language is the greatest, and I see all of you selected Java, so that's good. That's awesome. And also particularly Java 25. So it's good to know that people have migrated. For the people on Google Meet, I don't know if Google Meet supports polls, but I'll look into it. If it supports polls, I'll also give you guys polls. Yes, Joe?
Yeah, so I don't know whether we can go to strange places with lambdas, but they can actually return a function also. So yes. So it's called curry, CURRY. Yeah, it's very popular in functional programming. So for example, there's this functional interface called function. So you can, yeah. Yes, that one. So the return can also be a function. Declaring it looks very strange. You can try a simple example. So yeah, function and then curly brackets are not curly diamond. Yeah, integer and then comma after integer. No, comma inside. Yes. Comma after integer and then add a function, another function, and then integer, and then comma integer, and then put add. Oh yeah, that's okay. Fn is okay also, and then is equals to, since a, and then that arrow once, and then b, and then another arrow, and then a plus b. So this is chaining a function. Yeah, but here it's a bit verbose, but in other languages it's very simple. Like, oh, by the way, what you're seeing is how people program in Haskell. Yes. Yeah. So you can call it like int x and then add fn.
So fn. So int
apply.
int
Yeah,
x.
that's
Okay.
yeah. But yeah, you can allocate here and then is equals to add that apply. Oh yeah, apply a or a number. Yeah.
Okay.
And then again chain. It's a chain. Yeah.
So I can apply as much as I want.
No, I think twice. If
I'm
not wrong.
yeah. It's limited to twice. Yeah. And
the reason why it's called carry, it's because this function chaining is similar to a method which has two variables.
Okay.
Yeah.
Oh.
And if those two variables don't relate each other, then you can create a function this way.
This is very
Yeah, it's
interesting.
similar. Yeah. The world of functional programming, it's very interesting. So that's why mathematicians, actually it's a mathematical theory. So people used to go crazy trying to figure out this kind of properties.
Yeah, this is super interesting. So I basically just added 5. So I added 3 and then added 5, and we end up with 8.
So it's like a function called add, and then 3, and then 5.
If we wanted to chain it further, we could do function.
Yes, you can go. Yeah, you can go further if you want.
Integer and then so okay, it might okay.
And comma return type, I think.
Yeah, like that.
And then at the beginning, sorry.
I'm already lost. It's too much.
No. You actually are correct. So comma integer, and then after that diamond return integer.
So after the diamond,
Yeah.
Oh, then we have another integer.
Yeah, I think it will work.
Okay.
Now, the chain now adds C after B.
Okay.
C, and then
so C
plus supposed to return an integer.
So it seems it can't even cannot be applied to integer and function.
Sorry, we inverted. So you see that integer should be the other way around.
This one
after that function. No, yeah, you can copy that integer. You see the inner function here.
This one or this one?
You see the function with the integer inside?
Yes.
The one with the third one now.
This one?
Yes. Should be interchanged with the other one, I think, yeah.
So interchanged with?
There, and then add integer, the integer, add comma. And then Control V.
Oh, like that.
And then say A plus B plus C.
Okay.
Yeah, now it works.
Okay.
Now, yeah.
So we can have an extra apply here. For
10
and yeah. Yeah, it's so nice, but the code, the resulting code will be hardly readable. That's the only downside.
Yeah, so when you see Haskell code, just think of this. Just remember this.
And this goes back to the other thing I was saying. We can have these features in the language, but you can still write the post Java 8 Java. You can still write pre-Java 7 Java, and you'll still be okay. You can still do OOP. You can do imperative. You can even do aspect-oriented programming if you want, but the language doesn't force you to adopt this. I think that's what I like about Java. So like if you're not able to adopt it, you are safe. But anyway, we will dive deeper into these concepts in the next, not in the next, I think there's a session there's a particular bit we are supposed to cover before we go into functional programming. But when we go to functional programming, we'll be able to cover a lot of these concepts. Yes, Jim?
Just go back to the code. You notice that just click the function so that you go to the actual function interface.
Oh, yeah, this one.
The method signature is a bit strange. Okay, the idea is that, go back, when you notice here, you start with a type and then return, and then type, and then a return. So the way we define method signatures, I'll show you tomorrow, is that every method has a way of defining its own signature. For example, if I want to, if I'm going through the bytecode in Java, and I want to know how the structure of this method, it usually starts with the return type, and then the method arguments. So yeah, so there's a way methods can be encoded in bytecode, and there are classes to actually save the method signature and then pass it around. I'll show you tomorrow about a special class called method handles. It's a very interesting class, but it's the same idea here. Yeah.
I can imagine they use that for optimization.
Very, very, very. Yeah.
That's nice. That's nice. Because methods also occupy memory. I think is it stack or heap memory? Because you have to load the function into memory and then
Yeah.
load the data, and the CPU will use the function and the data to perform the operation.
Yeah. But sometimes you might not know the okay, the method might have very weird variables like object, the var args object. But what if you can tell the compiler that when I'm executing this method, I can present it with the method signature, the description, so the compiler can take advantage of that and generate proper bytecode. Yes, so, yeah, but I'll show you tomorrow. Yeah.
So tomorrow, 9 p.m. 9 p.m. Sorry, 8 p.m. to 10 p.m. East Africa time. We'll be looking at foreign function and memory API, which I think I can now safely refer to a replacement of the Java native interface that allows you to refer to low-level code like C and C++ from your Java code. So Joe will be taking us through that, and I hope you guys join us and don't miss out. Yeah, so don't miss out on that, and like Joe has promised, you will be able to look at additional capability in the Java language for these functional programming concepts, and it will be even more interesting. So don't miss out on that. Otherwise, I think I should let you guys go, unless there's a question or comment. I've kept you guys beyond the stipulated time. It's beyond your bedtime. I should probably end it there. So I'll see you guys tomorrow for the foreign function and memory API discussion, and looking forward to learning more. Tell a friend to join us. Okay. So you guys have a wonderful night. See you guys tomorrow. Have a good one.